Welcome back to my YouTube channel. So in this video we are going to go through primitive data types in Rust, but before that we are going to get into some computer science basics about bits and bytes to understand the data more clearly. So let's dive in. So following are the primitive data types in Rust. We have unsigned, signed, char which is for character, bool which is for boolean. In unsigned we see U8, U16, U32, U64, U128 and usize. In signed, we see I8, I16, I32, I64, I128, and I also put here F32 and F64, which are basically float point types or decimal types. And we also have ice, but we are not clear what exactly this 8 or 16 or 32 means. For that, we'll have to dive into some computer basics. So let's do that. So everything in a computer is ultimately saved in the form of zeros and ones. The smallest storage possible in a computer is a bit, which can either be 0 or 1, which is similar to a light bulb, which can either be on or off. So if we combine 8 bits, it forms a byte, and byte is the smallest storage for saving character or a number. Now we are again back to the primitive data types in Rust. Now we can understand the 8 here stands for 1 byte. In 16 we have 2 bytes. In 32 we have 4 bytes. In 64 we have 8 bytes. So we can simply divide by 8 and we can get the number of bytes. So this is how a number is stored in memory. So here we have a U8 47 which is stored in this form, and the leftmost bit defines if the number is positive or negative. If it's 0, the number is positive. If it's 1, the number is negative. Now, how to calculate the range of signed and unsigned? Here we have 8 boxes. In each box, we have two choices, either 0 or 1. We can either put a 0 here or we can put a 1. Similar for all the other boxes. So the combination can be 2 to the power 8, that is 256. So including 0, we can give the range from 0 to 255. So that's how the range comes. And this is how we can calculate the range of the types. For U8, we can go from 0 to 2 to the power 8 minus 1. That comes out to be 0 to 255. Similarly, for U16, it's 0 to 2 to the power 16 minus 1. It's 0 to 65536. And for I8, since it can either be positive or negative, so the range is different. So for I8, the range is minus 128 to 127, which sums up to the 256 numbers. And similarly, we can calculate for I16. So what is usize and isize? Usize is actually unsigned, isize is actually signed. So anytime you use usize or isize, the range of the number will actually depend on the system architecture that you are using. So if you are using a 32-bit system architecture, then usize will be equivalent to U32. If you are using a 64-bit system architecture, then usize will be equivalent to U64. Similarly for isize, if you are using a 32-bit version system architecture, then it will be equivalent to I32. And if you are using a 64-bit version, then isize will be equivalent to I64. These are the details of the system I am using. So it clearly shows that it's a 64-bit operating system. So usize will be equivalent to U64 and isize will be equivalent to I64. So float point or decimal types in Rust can be of two types. They actually follow the IEEE 754-2008 standard. So it can be F32 and F64. F32 is 32-bit single precision. F64 is double precision. Precision here is the accuracy of the number up to a certain digits. Float point number can be represented in the following expression: m cross b power e. M here is mantissa, b here is base, e is exponent. For example, let's take a number 123.45. So m here is 12345, b here is 10, and e here is 10 raised to minus 2. And if the magnitude of the value is greater than the following expression shown below, then the result is infinity. So this is how single point precision work. We have one sign bit, 8 exponent bit, and 23 mantissa bits. And in double precision format, we have one sign bit, 11 exponent bit, and 52 mantissa bits. Rust also provides us with some inbuilt constants that we can use. So we can use std colon colon f32 colon colon constants, and then we can use all these constants that are already provided by Rust. So here we have Euler and also pi and all the different constants that we have in mathematics. Now let's talk about char. Char is used to represent a letter, a number, and also emoji. And in Rust, it is actually UTF-8 encoded, which can store these number of characters. It can hold character from many different languages like Hindi, Japanese, Chinese, Korean, etc. This is how we define a char in Rust. We can do let's see and then single quotes A. We can also do let's see then single quotes 1, but we cannot do any arithmetic on this one because it's not a number, it's a char. We can also put an emoji in char. Here I've put a rocket emoji, and in Rust, char actually takes 4 bytes. So how a char is stored in the memory? When we define a character in our code, it goes and looks up into the Unicode table and finds the equivalent decimal value, and the decimal value is then saved in the memory as a number is saved in the memory. We now have some basic understanding of primitive data types in Rust. So now let's dive into some coding. So first, what I'm going to do is I'm going to define a number and I'll print it. So anytime you want to print a number, you can use the println macro. Macros we are going to discuss later on. Then you can give the number. Now we are going to run our program using the cargo watch command that I showed in the previous video. We get 30. We can see that I haven't defined the type of the number and it is automatically inferring it as I32. So Rust is very intelligent. Anytime you don't define the type of the number, it will infer it as I32. Let's now change it to I8. It works perfectly. So the range of I8 is from -1 to 7 to 1 to 8. So if we change it to 1 to 9, it's not going to work and it's going to throw us the error that it's out of range. It will also show us that the range is this. For this actually we'll have to do I16. So now it's going to take the value perfectly. In I types we can also put negative values and it's going to work perfectly. Now let's change it to U16. It's not going to work because in U16 we can only give positive values. So let's make it positive. So now it works perfectly. So let's change it to U8 and then try to give a value greater than 255. It's not going to work. Anytime we define a U type or a I type, we have to give the value that is in its range. Rust also provides us with some inbuilt methods that we can use to get the min and max of a particular type. If I write this code and then I run it, 0 to 255. Similarly, for all the other types, we can do that. Following is the code snippet to get the min and max of all the I and U types. Let's run it. So here we get all the min and max values of all the types. Currently, I'm running my code on a 64-bit system architecture. So what will happen if I define my variable as U128? The code is going to work perfectly, but it's going to be less performant because internally it's going to use multiple registers to do the arithmetic calculations and it will not be as performant as we are expecting. Now let's have a look at the floating point data types. So this is a floating point data type. Anytime we don't provide a type for it, it's going to infer it as F64. So if you want to use F32, then you need to define the type. So let's change it to F32. This is how we can define a floating point data type. We can also use one more syntax to define the floating point data type. We can put F32 after the number. Now let's print it. Now let's run it. Works perfectly. We can also give underscores in between the floating point data type. We'll give exactly the same results. Plus provides us with some methods that we can use on the floating point data types. So let's have a look into them. We can round a number. So it's going to round it to 2. Let's change our number to a negative value. Now let's do the absolute of that. It's going to give us the absolute value, which is the positive value. We can also use floor, which will return us the nearest largest number equal to or less than self. We can also use sealed, which is going to return us smallest integer greater than or equal to self. Now let's try to add one F32 and one F64 and see what happens. Let's see the results. So it's going to throw us an error. So in Rust, we cannot add two different data types. The float point types also support infinity and not a number. Let's have a look at them. We get the output as INF, which is infinity. Now let's change this program and let's see what will be the output. We get NaN, which is not a number. So now let's have a look at the character data type. So for defining a character, we need single quotes. This is a character data type. We can also put a number in single quotes, but we cannot do any arithmetic operations on it. Let's try to do some arithmetic operation on B. Let's see what happens. So it's going to throw an error. We can also put emoji in char. Here I'm able to put the rocket emoji. Now let's print all the characters. It runs perfectly fine. Now let's have a look at the Boolean data type. So anytime you want to define a Boolean data type, you have to give the token bool. So in Boolean, we can either put a value of true or false. Boolean only has one bit of information, but in memory it takes 1 byte. Let's try to print this. We get the value as true. We can get the Boolean value from comparing two expressions. So let's try to do that. Since 8 is greater than 7, it's going to give us a false. The value is false. In this small snippet of code, I am trying to use num as truthy or falsy value, but it's not possible in Rust like in other languages. Let's try to run it. It's going to throw an error. We can also cast a number from one type to another type. Let's have a look into this. Now we'll cast it into a U8. Let's try to print it. It gives us 43. Since the range of U8 is only from 0 to 255, so anything greater than 255 is again going to cycle it from 0 to 255, and hence we are getting the output as 43. This is it for this video. If you like the content of this video, make sure to like it and also subscribe to my YouTube channel. And thanks for watching the video. See you again.